All right, happy Thursday. Thanks for your time meeting Amy. She's a fantastic librarian. Super cool that we have our own dedicated librarian. I mean, I guess she does math stuff too, but we'll call her the engineering librarian. Uh, so the reason why we want to talk about the Hoover's database is the goal with the final project is for you to use Python libraries that actual companies are using. So we're going to put together a spreadsheet and we're going to break into your teams for the final project. So ideally, we're going to do teams of 3. So we should be able to get 20 teams. I think we got 60 people in the class still. They might have, I think maybe 2 people dropped. So we're pretty close. Maybe we'll have one team of 4, but we're going to default to teams of 3 for this project because we don't need 60 presentations in a 3-hour slot. That just won't go well. And working in teams is obnoxious sometimes. I get it. I understand. But you're going to self-assign to your own teams here. So hopefully you got to know somebody. And what we're going to do is go reach out to actual companies and say, hey, I'm a student. I'd like to do some, or my project, whatever. I'd like to learn more about the libraries that you're using so I can become familiar with them. So we're going to reach out to a bunch of different companies. We'll put a spreadsheet so you're not all emailing the same person. That poor CTO, usually the chief technical officer, would know that sort of thing. And they're probably pretty easy to find. They scrape a lot of LinkedIn data on the Hoover's database. So we're going to reach out. Put whoever you reached out to in the list so we're not double contacting people. And ideally, in the next month or so, before we start our final project, we'll have a list of, here's a bunch of Python libraries that people are using. Right? There's a lot of really popular ones that almost everyone are probably going to be using, depending on what they're working on. But ideally, we're getting some of the more interesting ones, more specific ones as well. So I know there's a lot of them. I'm going to talk about a lot of the common ones here. The best that I can in the last 3 weeks of class for that, just touching on some of them here. But the goal is find the library, figure out how it works, because there's a zillion Python libraries out there, and do something fun with it. It's going to be very open-ended here. It's got to be a big enough project. So we're going to start in our groups. You're going to propose an idea, right? So we're going to start a group project on the 24th here. So we've got a whole month to do it here. So ideally, by the 24th of March, we've got the list of libraries because you've all reached out to somebody here. And then your team will say, hey, I want to do something cool with PyTorch. Great. Okay, so what's your idea? What do you want to do with it, right? Just getting it up and running is a small headache for a lot of these libraries. They're very specific about what versions of Python they even work with, which is its own nightmare sometimes. So trying to get, hey, this is the newest, latest, and greatest machine learning library up and working is going to take a bit. Right, to even get that step up and running, making sure we got the right versions, the right dependencies. It uses other versions of other things here. So it's interesting. There's a lot of stuff that goes into just that. And then what do you want to do with it here? Right. So what is your team going to propose that your project is going to do? And then our group project presentations, 8 a.m. on my birthday. Not salty about it all here. You'll have about 5 to 10 minutes or so with 20 teams. We can't take 10 minutes each, but somewhere between 5 to 10. We can get through all 20 teams in that 3-hour window here. You'll present what it does. So here's the library looked at. And it's okay if more than one team does one library, but not all 20 teams should do the exact same library. It'll be a really boring morning, right? So ideally, if we're spreading our things out here, hey, I looked at pandas and here's some numerical analysis that I did because I really like numbers and statistics. Great. That's really cool. Like, what sort of things did you do with it here? That's sort of fun. So pretty open-ended in terms of what this is going to look like here. So we'll start it on the 24th. You'll have a check-in with me on the 7th is the idea here, where the 3 people in your group said, okay, here's what we've done so far. Here's what's left to do. And at that point, if you want to fire someone from your team, fire them. Say, hey, we've had 2 weeks. They've done absolutely nothing. They get kicked out of your group. You cannot pass this class without the group project. Okay? It's just mathematically impossible. Right? And you're not allowed to do it by yourself. So don't get fired from your team. Right? Be a contributor. If you're not contributing, you're not going to get points and you will fail the class and you'll be pissed off at me. And I'll say it's your own fault. Right? So help out. But you'll check in on the 7th. We'll have, here's a little thing. How are people doing? Here's what we've done. Here's what needs to happen still. Ideally, you get it done by the 16th, and then your finals week, you've got nothing to do for this class, and you can focus on the rest of your classes, because you all have lives and other things, and some people really like to test if you can memorize stuff. I've never understood that, and I hated that in school. Thankfully, I had a good memory, and I did okay. When I went back to school to take calculus, to get into the doctoral program, at 30, my memory was not as good. And I failed Calc 2 because I couldn't memorize all the stupid formulas, and the teacher wouldn't let us use a formula sheet. The second time I took it, that prof let us use a formula sheet and I passed. Amazing. And probably, sitting through the lectures a second time probably helped too. Um, but that sort of thing. So if you need a little more time, great. It's up to you guys whenever you want to finish, but you'll present, hey, here's the library work done. Here's the cool thing we did. Ideally the goal is we do something analytical data science related. If your project doesn't, that's okay, right? We're going to talk about some of those things when I go through Python libraries. So if you want to look up, hey, here's a cool Python library that lets me build graphical user interfaces, and you want to build a silly little game, I love games. Go for it, right? And I'll show you, my goodness, tkinter, which weirdly doesn't use py in the name. Like you assume all libraries have py in the name. You can build UIs, which is really fun. So I'll do a quick demo of tkinter one of these weeks here. You can do a lot of fun stuff with it. Build a game, go for it. If you want to use a library that lets you build web applications, there's a really good one, and I don't remember the name off the top of my head because I just don't have a good memory anymore. There's a really quick and easy way to build web apps in Python. You want to build a web application? Go for it. That's cool too. So don't feel like it has to be a data science project here. Ideally, we're going to cover things that can let you do those. But, if you want to do something else, that's great. You all have varied interest. If you want to do a cybersecurity related project, I love it. I'm here for it, right? Whatever your team gets interested in, I'm good with it. As long as you've checked in with me and said, hey, I want to do this thing. And I say, that sounds great, right? If you're like, hey, I want to build a program that counts the numbers of pi or counts the digits of pi, that's probably not very interesting, right? Not enough work for three people, that sort of thing. So a significant amount of work here. But it doesn't need to be crazy. You don't need to build a fully featured everything, amazing tool. It's a 200 level class. Let's set some expectations at a 200 level class project. Okay. It's not your capstone. It's not your senior design project. It doesn't need to be 2,000 hours, right? But across three people for 4 weeks, right? You're probably spending 6 hours outside of class, right? For every three credits, that sort of thing. So 6 times 3 times 4, 18 times 4, 70 hours ish, somewhere close to that. I can't math right now. I'm still really tired. I had a morning meeting, which was stupid. Uh, Mornings are the worst. But that sort of thing. So what can you do in 50 to 70 hours of work here? Should be something cool. And you're going to present it to the class. And if yours is not cool, everyone's going to see it. Right? We'll be honest. That's okay. But the goal of presenting is to get comfortable. When you get into industry, that's what you're going to do on your team. Hey, here's the thing I worked on, team. Take a look at it. Give me some feedback here. Right, what's a safe space? We're going to give you some feedback here. Obviously, it's scary because it has so many points attached here. It's going to be really easy to get the points if you put the time, energy, and effort into it. Okay? Right? So, a rubric is a little bit tricky to show. You're going to get points for selecting a project, presenting it to me. You're going to get points for your check-in. You're going to get points for being a good team member. And then you get points for doing something cool. Right? So you can get lots of points here without it being this crazy huge project, right? Just, pick something ish, that's okay. So what we're going to do in the next month, we're going to reach out to individual people using the Hoover's database, generally the CTO or maybe manager of engineering or something like that. I figure you guys are smart enough you can find who. Don't ask the CEO. They have no idea, right? They're the CEO. They have no idea what tech they're using, right? Don't waste your time on that. Focus on the technical people here. And just a quick email like, hey, I'm a student working on a Python research project. Can I have 2 minutes of your time? I would just like a list of the libraries that you're using because we want to research libraries in use in real companies, right? I could tell you a list of Python libraries. Sure, that's fun and all, but go ask a real company and figure out what they're actually doing here. It should be fun. That's the goal here. If it works out that nobody has any answers in a month, that's okay. We can Google popular Python libraries, but having gone through this exercise, I think it'll be useful in finding out what actual libraries are in use would be really cool. The internet has a weird way of hyping up things that aren't necessarily always that popular, but because it gets a lot of traction and a lot of conversation about it here, it seems like it's much more popular. It's this weird circular thing here. So as it gets more popular, you hear more about it, but it doesn't mean everyone's using it. That's all. So I'd like to see what we're doing with that. All right, make sense? So I'll post that. I'm going to have a link to a spreadsheet. So when you do contact a company, put their name in the spreadsheet. And then before you contact some company, go look to see if their name's already in the spreadsheet. Not going to be too hard, like a shared Google Doc. It's probably easiest for that here. That way we're not all emailing the exact same person, right? Because I think they'll get pissed off if 60 people all email the leader CTO, right? Okay, so just try. Yeah, so check the table first. We're just going to put company name. Like I don't even need like individual names. Just if you've already contacted that company, skip it. Or if someone else already contacted them, skip it. Go to a different company. We've got like 40,000 or more, right? That this database says uses Python here. Uh, so it should go pretty well. I'm excited to do that. I've not had a chance to do this. I usually do like the 100, 200 classes that are like the intro to programming. We never get to do anything fun because we're doing linked lists, which are terribly dull. Here, don't write your own linked list by hand, please. Right? Use the library. That's why we've got libraries. Really smart people have done these libraries here. So it should go pretty well. All right, and then we got to talk about our next project. So we got through Python classes, we got through unit testing, right? Okay, so the project we're going to do is going to use classes and testing. Yay! It'd be fun to do some of the web stuff, but again, it's okay. I want you to know what's out there. You can go play with it if that's the kind of thing you're interested in here. Uh, Really cool around automated testing of web applications. If you can say, hey, go out and click this thing, click this thing, click this thing, it was really nice and fun to do a more end-to-end test. Right, once it's actually deployed, is really nice and big. There's some really cool tools that people use and workflows that they have when they do the continuous deployment. We talk about continuous integration testing. Yeah, okay, so that's the fun part here. So if we go to like Microsoft's VS Code repository, an open source tool here, every time a commit is made to this repository here of 130,000 commits here, it goes out and runs unit tests or whatever level of tests they've specified. I don't actually, some might be larger than that here. So you can see, hey, when they did this thing, 3 out of 3 tests passed. So you can automate as code gets checked in, tests run, which is really nice. So it gives you confidence that things are running, and I don't have to do it on my machine because sometimes they're not super fast. Some of these tests can take a little while here, and you don't always want your developers wasting 15 minutes of time for these tests to happen. Or some of them, depending on what they do, will spin up a virtual machine and do cool stuff on that and make sure this level of testing works at this thing here. So if we can have continuous integration testing as code is integrated into our code base, into source control here, we test it, right? Then we're feeling pretty good this change was successful. If you've got automated tooling for that, the next thing you can do, depending on your application and what it is here, it works really well for web applications here. It's a little bit trickier for installed programs, but there's ways to. You can have continuous deployment and say, okay, if all my tests passed, go deploy this code to production automatically here. Go put it in the hands of the end users. So I've got a couple buddies who work at Khan Academy that I used to work with. I moved over. Khan Academy gets updated dozens of times a day with live code from their engineering department. So whatever they're working on, they can check in the commit, and the rest of the tooling, the pipeline, takes care of, okay, let's make sure the test passed. If the test passes, let's go push it out to production. In general, when you talk about software engineering and being productive and being able to make changes and to, Khan Academy doesn't really make money. They sort of make money. They're a nonprofit. It's a little bit sketchy here when nonprofits make money. But faster you can get your engineers to get code features into the hands of end users, the quicker you can be adaptable, the quicker you can change things, the faster you can be making changes to your code, the better it is. Because you don't want, hey, I worked on something here that someone requested 3 weeks ago. It took me a week to work on. I put it out into a test system. It took another 4 weeks for someone to actually go and test it. It took another 4 weeks for them to actually go and install it, to try it. You've got like a 3-month disconnect between someone asking for a feature and them actually getting it in their hands. If you can shorten that time, you're going to satisfy your customers more, and you're going to be better able to see, hey, was this a good feature that we rolled out? Did I have anything I need to change? If it took 4 weeks for a user to actually get it and give you feedback, you forgot what you did 4 weeks ago, right? I was just in that feature 4 weeks ago. I've had other work I've been doing here. Now, if they want something changed, I would really like it to do this, or, this was great, but how about this? You've got to go relearn all that stuff that you were working on. It's a big pain in the butt, right? Software engineering is a very high context. You need to be understanding what we're doing and switching between contexts and saying, hey, I'm working on this feature, I'm working on this feature, working on this feature is very costly for engineers because it takes a lot of time, energy, and effort to get up to speed, to focus on what we're working on as we're going. So being able to continuously deploy, it's super nice. Web applications is great. I don't know if you noticed here with GitHub, every now and then it's like, hey, there's an update. Do you want to update GitHub? 298. I think I pushed my code last time. Yeah, I did. Great. So certain desktop applications can be auto-updated. that sort of thing. So you can go through this sort of pipeline and say, hey, that code's ready to go, and my application will go look for updates. It's updated like 3 times in a day. One time, I like really, they must have broke something with one of their updates here. I don't know. All sorts of fun stuff around that. And then other cool things, you'll probably learn all about software engineering process classes and things. Um, being able to update code is good, but being able to test it, right, with a small subset of your users is even better. Right? Before you just go and release an update to all million of your users, whatever happens to be, it'd be nice if you gave it to a subset and made sure it worked. It didn't break anything. This idea of it being a canary testing, so you don't end up breaking all the Windows 11 machines or Windows 10 machines in the world. Do you guys remember that? Was that last year? Here's 2024. Um, it breaks. It was 10. Who was it? Cloud. Yeah, Cloud Strike. Cloud Strike. I don't remember what. So they didn't test it well. So like, if your software auto updates, you shouldn't auto update everybody all at once, right? There's ways to not do this. So they had some bad practice here. So this is one of the downsides. If you're doing it badly, you just broke everything here. So this was, yeah, July 24th. A lot of my friends in IT support had a really bad week because you had to physically go to every machine here, which is really hard for machines that are like terminals or like the luggage display at airports. For some reason, that runs Windows and they have to go like plug into it to go reset it here. That was a big pain for a lot of people. So, unfortunately, so good idea can be bad if you do bad things, right? So it passed their tests. Apparently, I don't even know what testing they had here, how that all happened. But worked on my machine. Sure, I like. Okay, yeah. So all you had to go do is delete this, and then you're fine. But what a mess! What a mess here. So, really want some more coffee. I've had a morning meeting, which is awful. Okay. All right. So the last thing we have to talk about is the next project here. So this will take us um, through. This will probably be the last one we do then, right? Because if we're doing one today, the 20th, that'll be due the 12th. We're going to pretend that week doesn't exist, and then we'll start the final project here. I wanted to try and do one more with data visualization, but that's okay. We don't need to do a project on that, so we can call that one good here. So one more project. This is project 3. So 2 weeks, but we're going to pretend spring break doesn't exist, right? So that'll put us out to the 13th at 9:30 in the morning. Yes. I have to click that box, right? And this will probably be worth, I don't know, let's make it 20 points. Because we're going to use, not the web stuff, but all the other stuff we're going to use here. You submit the URL of your repository and include a self-assessment using the rubric in the README along with screenshots of it running. Okay, so I'm fond of, that's not really a puzzle, but those sorts of things here. So have you guys heard of the Enigma machine? There's a really great video that Numberphile did on YouTube here. Yes, there's plenty of these out here. We're going to do it in a specific way that uses classes and we test them because I think it's important to know if your code actually works here. But this is a super fun video here. You can go take a little bit here and watch the Numberphile video about the Enigma machine. So this was, yeah, we're going to build our own Enigma in Python. Not crazy hard, right? It's definitely doable, but I'm going to ask you to build it in a very specific way using object-oriented programming. That's not what the chatbot gives you, right? When you just ask for Enigma in Python, it gives you like, here's 100 lines of code just in a main file. It's really ugly and terrible and not flexible and not testable, right? It's bad practice. It's just crappy, sloppy code. It works, sure, but it's sloppy code. It's not useful here. So what this did is encrypt messages. Back in World War II, the Germans came up with this here, and then Alan Turing, he wrote the bomb machine here, which is what we'd like to imagine is one of the first computers. It was not really a computer. So like the electrical engineering people, you can argue with them about whether or not this was a computer. They're going to say yes. I'm going to say no. again, it doesn't really matter what I think here. So the bomb machine was super cool with an E here because they're British, right? Of course, they're fancy here. And we're basically making a cipher. Well, we're going to make an Enigma machine that will encrypt messages. Yep. Um, so he was able to reverse engineer it, which was super cool, and crack the code. It turns out it's easy to crack because of a specific flaw, and you can read all about that or watch all about that in the number file video. How we crack these things here. Um, the Germans were very particular here. And if you start every message with a particular phrase, it makes it much easier to crack. So if they would have just randomized their starting phrases or not had a starting phrase or like not done weather reports over this, World War II might have gone differently here. But so the Enigma machine was super cool. We can even do the Wikipedia link for that one too, right? Enigma machine. Here we go. Let me add this one in here for you. Why do I lose my cursor? This is the weirdest feature here. You can see it on that screen, but I can't see it on my screen. Like my laptop's possessed or something here. Okay, so we're going to create, so using object-oriented programming techniques, write a Python version of the Enigma machine here. So a couple things, right? The reason why we like object-oriented programming is because it's a natural way for us to talk about software, right? We like classes as here's a particular noun, and we like the verbs to be the functions that they do. Their API, your application programming interface, your public functions should be the things that you do. Right? Get and sets are kind of boring. What features do you have? How can I interact with you? Right? So we need to be able to make an Enigma machine class that takes some pieces of information. Right? So we're going to have a class for the Enigma machine. Enigma machine. The init accepts a couple parameters. So we need to know the way the Germans built it, there were 5 different rotors, and at any given day, they would use a certain 3 of them. And they had a whole sheet, right? And those, all sorts of fun things. They wrote it in like water-soluble ink for their boats, which was fun. So they could just throw it in the ocean if they were going to get captured. So we wouldn't know what codes they were using for that month here. So we need to know the 3. I'm sorry? You'd probably get in trouble. Yeah. 3 rotors that will be used in which order, right? So 5 permutation 3, right? So you've got 5 rotors. I'm going to use rotor 1, rotor 2, rotor 3, or rotor 2, rotor 3, rotor 1, right? Different order, and they do different things. We'll talk about it, how that works. We need to know the 3 rotors and which order they are in. We need to know which position each rotor starts in, because each one had a position, right? Each rotor represented a character, and it would map to another character. So with this particular rotor, it was all electronics, which is super cool. They could do this with electronics back then. If it got an E input, it would give you a different letter output here, right? So E comes in, and then something else comes out. And then what happened is every time it turned, you'd get a different output. So E going in the first time would give you, say, F. Then when it rotates, the next time E comes in, you're going to get a P. And the next time it rotates, when E comes in, you're going to get a Z. Right? So it changes the mapping as it rotates, which was super cool and made it harder to crack as a cipher because it changed every letter. Right? So it looked like this big typewriter machine here. And these little rotors would spin, physically, mechanically spin every time you typed a letter. Right? So to set it up here, you would say, okay, I want this rotor, this rotor, this rotor at position 10 and 12 and 1. Great. Now when I type in my message here, I get an encrypted output here. And then to decrypt that message, you just start the machine at the given position and feed in the encrypted message, and you get back out the plain text message. Right? So if E mapped to G on your first keystroke, and then E mapped to N on the second keystroke, if you set it up the same way with the same 3 rotors in the starting position to be the same, when you give it P and N, you'll get back E and E, or whatever letters I just said, right? So it's reversible if you give that same position, right? So one letter maps to another letter, both directions. So E will always map to N if they're in this position, and that means N will always map to E because they're physically connected by wires, right? So this letter maps to this letter, and vice versa. That's how it's decryptable. which is super cool. So if you tell it which 3 rotors and which positions they start in, then we're able to set it up. The next thing these things had, which is another level of complexity here, because this one blows my mind here, they had what's known as the plug board. So they had, in addition to that, of the 26 letters, they had 10 pairs of cables that did one further level of mapping. So you can say, okay, I want A to actually map to B. And at some point in here, I forget the specific sequence, it hits the plug board and changes that mapping here. So the setup they had every day was 10 pairs on your plug board. So 20 letters out of the 26 in combination, not permutation, right? Because that's just A always maps to B, or B always maps to A. So it's going to be combination here. It's a super large number here. And I think that's how they get the millions, billions, trillions, quadrillions, centillions, 158 centillion possible combinations for this thing. Right? With 5 rotors combination, with 26 positions per rotor, and the plug board 20. So he goes through all the math on his brown paper number file. Super fun here. You can go down YouTube rabbit holes if you really like math, that sort of thing here. And he's like brown paper is his classic thing for some reason. Lots of fun. Yeah, you can even go read about the flaw here. So he goes through it. He's got another video about it, which is fun. Anyway, so we're going to write our class, the position each rotor starts in, and the 20 character plug board settings. So with the 20 characters here, so we'd say something like 3, 2, 5, right? And then positions like 24, 12, 11, right? And then you give it 20 letters, right? So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. I got 20. I don't know how that happened. I got super lucky, right? So with 20 characters, the first 2 are mapped, the second 2 are mapped, the third 2 are mapped, right? 2, you get these pairs, 10 pairs of characters here. So we create an Enigma machine, you tell it, here's your settings for the day. Good news, right? Then you can either encrypt or decrypt a message. Okay, so we got the class Enigma machine that takes that here. We're going to have a class for rotor here that accepts a rotor number here, and a position, starting position. So in Python here, I can actually fire up PyCharm for once here. PyCharm. Did anyone else notice Python was spelled wrong in the DMD database? The first Python, the second Python was spelled right, but the first one was wrong. I don't understand that, but that's okay. Let me go start a new project. I want to show you when you create random numbers here. Did we talk about there's a way to seed it? Okay, so seeding your random values here is super important because it means you'll get a predictable sequence of random numbers. It's pseudo-random. So this is week. Here's random.
I know it's equal plus as red,
Mhm.
so I know.
Yeah, so we can seed it the same way so that you'll get the same sequence of random numbers. Turns out if you seed it with a rotor number, you'll get the same sequence of random numbers for that rotor. Great. And if you want to go to position 26, you just go get 26 random numbers first to start. It works out pretty easy here. So if you do import random here, we're going to import random and random.seed. We're going to seed it with, say, the number 2 here. We're going to print random.randint. I don't know. Let's just go to 10 here. Let's do 4 or 5 numbers here. And every time I run this, I'm going to get, oh my goodness. Oh, geez. 1 to 10. There we go. Oh, I should just put that in the for loop here. Or number in range 5, about 10. Yeah, we were doing 5, right? Here. So every time I run this now, I'm going to get the same sequence of random values because I seeded. So 1, 2, 2, 6, 3. 1, 2, 2, 6, 3. 1, 2, 2, 6, 3. If you don't seed it, what Python does is you use your clock time, which every time you run your program is different. So the default seed is our clock time. So if you don't seed it, you're going to get a different sequence of random numbers every time, right? You see they're changing. 6, 9, 3, 8, 4, 6. But if you do seed it, you get these same, because it's a pseudo-random here. So if you know what the seed is, you get the same results. So you can seed your rotor based on its rotor number, which actually means we can have like infinite numbers of rotors, right? Because you can seed from 0 to 2 billion. I don't know, 2 billion rotors would be stupid here. But sure, here's my X rotor number. It just takes its number as a seed, which works out really well. And then go get some random. So if you want to say, hey, start in position 25, go get 25 random numbers first. You've eaten the first 25, right? And then you'll start at the same sequence here as we go. So that's how we can start our position here. So rotor accepts the rotor number as the starting position here as we go. And then, so we're going to write a program that allows the user to encrypt or decrypt a message given some rotor setting, given the message, and pick the Enigma settings. Sorry, I'm running a little over here. And then we're also going to unit test our code here. So unit testing it, does it work? So if I pick this sequence here, I know what I'm going to get back out, right? Okay, so I'll put a rubric in. I can show you on Tuesday. I don't want to keep you too long over here, but that's what we're working on. There are solutions out there, but they don't follow this object-oriented pattern, right? Okay, so what we're doing is following an object-oriented way because we did that, and then we can actually test it in a way that's not, hey, let me put some input in and see if I got the right input out. I can make the machine test it for me using unit tests. So we can unit test the rotor itself. We can unit test this. We're going to need a class for, we need a class for the plug board as well, which does our mapping. Class for plug board and a class for the reflector here. So reflector here. So we have a couple different classes we're going to use in the Enigma machine. So it goes through 3 rotors, hits the reflector, and at some point hits the plug board. I forget when in that sequence here. I can draw you a picture on Tuesday if you want to see the picture, or you can watch the number final video. They go through all of it, which is really cool. Great. That's what we're going to work on in the next 2 weeks or 3 because we have got spring break. You folks take care, and I'll see you on Tuesday.